Okay, great. So as a review, what we have done so far, and maybe I can also summarize where we are in this journey. So in this journey, we are looking at doing data analytics. And for analytics to work out, we have seen that Python is an important language from the beginning till the end, starting from data exploration to visualization to pre-processing and developing machine learning algorithms and deploying them on the different environments. Python, is deeply integrated into all of these processes. And for this reason, we were looking into Python as a programming language of choice to enter into our world of analytics. We started with basics of Python, where we discovered or where we understood what are the advantages and disadvantages of Python. We started with operators and control structures. We then moved towards functions, which we finished in last class. And today we'll look into modules. Uh, Basically, where we are moving is we are moving towards looking at modularity within Python language, and as well reusability, where we can write reusable code that can work out for uh, present projects that we will work on. Also, additionally, how we can take the same codes and use it for the future projects to come. This is where functions and modules come into picture. Before going ahead, do you have any questions on functions? Okay. Were you guys able to attempt the assignment and solve them? Okay. Okay, great. So we'll go ahead. We'll discuss modules within this class. This is going to be a very short class, it seems, because modules is not so big, and I don't want to start the next major topic, which will, or maybe we can have some discussions and we can try some problem solving within this session as well. So, as let's go ahead. Okay. So within this class of modules, we'll look into the different import methods. We will look into how we can make our own modules, the use of this specific label underscore underscore name underscore underscore, and how we can differentiate between a module and a program, and what is the dir function. Okay. So as we have seen so far that by using functions, by defining functions, we can reuse our code multiple times. But what if we have to write a function and we want to use it in multiple programs? Okay, and the answer here is we use something called as modules. Now, uh, there's a very easy way of creating modules is whatever we have been writing so far, functions or variables, if we just store them into a .py file extension, then we are making a module. Okay, so Python, the way it is designed, it is highly it highly supports making of modules, using of modules, sharing of modules. In fact, the way many of the inbuilt modules that we work on are defined and used in the similar way. So common modules like NumPy or Pandas and so on, it works in a similar fashion. Okay. Now, a module can be imported by another program to make use of its functionality. This is how we can use Python standard library as well. Okay. So let's look at some ways. So to import a function, so let's say we are writing a program, and for that program, we require to use the square root function. Now, for functions like this, we don't even think or take the pains of understanding how the square root function would have been implemented. Okay, it is much easier for us to pick up a library and then start using it. Okay. So in this case, the square root function does not come inbuilt within the definition of the Python language. So we'll have to import a package that specifically handles how to get this done. The package that we'll import is called the math package. And here, the way we import it is we just simply write import math. And by doing that, we have access to all the functions within the math package. And one of the functions within the math package is the square root package, is the square root function. To access it, we can use like this. We can use math.sqrt of 16, and that is how we get the answer. The square root of 16 is 4. Okay. Now, in this case, we have to call it in this way, like math.square root, because we are importing the entire package math. Okay. And what Python does is when you import a package like math, it keeps the same name so that, let's say, within your function, you're writing a sqrt square root function. It should not coincide or it should not clash with the square root function written in the math library. But let's say you are sure that your program is short, you are sure that you are not going to create an sqrt function, then you may also want to reduce this extra math dot part. Okay, so the way to do that is now we will import from math in a specific way. We will use this kind of shape. We'll say from something, import something. Let's see here, we are doing from math, import square. So there are multiple advantages. Maybe there are few things of note here that now what we have done is from the package math, we are just importing one function. In this case, we were importing the entire math package and we were using only the square root. Whereas here we are just importing the square root function. So uh, this can make our program, what do you say? So let me put here. So it says that here our program becomes more readable, which is an advantage that it is, we don't have to write math.square root, we can just root square root. The problem is we may have clashes if you are having your own square root function. But as long as you don't have that, this is not a problem and we can use from math import square root. In fact, you can put comma and you can write any number of functions that you want to import from math. So let's say there is a sine function, you want to import sine, you write square root, comma sine, let's say cosine, and as many functions as are available within the math package and you need to use them in your program, you can do square root and you can keep writing with commas. So in this case, let's say we are importing two functions, the square root function and the gcd function. We have put this tuple and we are writing a comma. The tuple is not necessary. You may even ignore the tuple and just simply write from math import square root comma gcd. That should work out fine. And you can use the square root and gcd function for your program and use them without having to define them earlier. Okay. Let's say there is a case where you want to use multiple functions from the math package, and the easy way to do that is you write an asterisk here. So what we say is from math import asterisk, so import everything. So when you import everything, all the functions within math package are now available to use within your program without using the math dot prefix. You can directly use square root or GCD or any of the different functions available. That's correct. Is this clear so far? Okay. So let's look at how we can make our own modules. So now we have seen how to use a package from within Python. But let's say there are many cases where Python does not solve, especially when you're working in a very specific field. You may want to write modules or functions for you and your team. In those cases, you can create your own modules. The way we create a module within Python is very simple. Uh, all the programs that we have been writing so far, we just have to save them into the whatever file name you want to keep, .py. Okay, so this becomes a Python file. So far, we have been writing programs within the Jupyter notebook. And when we save the Jupyter notebook, we save it with an extension of .ipynb. This stands for IPython notebook. And here, if you take the same piece of code and we store it into a Python file with .py extension, you are making your own module. In this case, consider this very simple module. It is defining a variable and giving it a value. It is defining a function s, which takes two inputs, x and y, and it returns the sum of the two inputs. It adds it and returns the answer. Now, there are multiple ways we can import this. Let's say look at step one. In one, what we are doing is we are writing import sum module. So now the assumption is here that when we are running this Jupyter notebook, the sum module is accessible. So either the sum module.py is in the same folder where you're writing this notebook, or the sum module.py is in a path which is accessible to your Jupyter notebook. Okay, so long these two conditions, either of those conditions are true, you can write import some module. And when you import some module is now accessible in your program. You can do some module.s, which is the name of the function here. Give it two values, 100, 200, and print its result. So we know is a summation function. It returns 300. Or you can do print some module.v1, and then you have access to this variable 100 and it gets printed. The other way of importing from the sum module is doing from some module import individually whatever we want to import. So in this case, we are importing S and V1. Similarly, S is now accessible for your programs. We can write S 100, 200 gives 300, and print V1 gives us 100. Third way to do that is doing from some module import everything. So if everything gets imported, in this case, everything is just means two objects, a variable and a function. And we can see that we can use both the function and the variable here in the module. Okay. Now, this brings us to the next part where we discuss what is underscore underscore name underscore underscore. Okay. So every module has a name, and statements in a module can find out their name, the name of their module. Okay. This is handy for the particular purpose of figuring out whether the module is being run standalone or being imported. Okay. So let's say you write this Python file. Okay, this Python file. Now, when you execute this file, we can see that V1 will get executed, and this sum is available. And when you are not executing it, in this case, in this program, we are actually importing it as a reference file. So what is the way of knowing when this file is, when the sum module is being imported and when is it being executed independently? And that is where we come across the name attribute. And the name attribute looks like this. When the program is being run by itself, that is when you're running this program independently, the name module takes this value. It takes the value underscore underscore main underscore underscore. Okay. So if within the piece of code, we have to check what is happening, I can use the name attribute here, see its value. If its value matches underscore underscore main underscore underscore, then we know that the program is being run by itself. Okay. And if the name value, the name attribute is not this, then the program is being imported from another module. Okay. So we can do a simple check by writing the print statement for both these cases, and let's import it in different ways to see how it works out. Okay. So let's say if we run the program directly, the way to run a .py file directly is using your terminal block. Okay. So within my Python terminal, within my, in my case, I'm using a MacBook. So here I use something called the terminal, and within the terminal, when I write Python space, let me write this neatly. I write Python, and let's say I am in the right location of the file. I write name Python and then space, and then I write the name of the module. So in this case, let's say if I write some module.py, then this Python file gets executed within the terminal. Okay. If you are using on a Windows system, you may run it in the command prompt. If you run it in the command prompt, you can do the same thing. You can write Python and space and the name of the module if you are in the right location. Okay, so when you do that, you can see that the program gets executed and we get this result, that this program is being run by itself. Other way, let's say if I am not running the program in standalone, whereas I am calling it or importing the function. When I do something like this, import the module here, so import some module. What happens is I get the statement, I am being imported from another module. Now this gives us the flexibility of writing one piece of code and executing it differently when it will be run itself, and executing it differently when you are calling it from a module, okay, calling it from some other program. Additionally, this is probably one question that Anand had long back, was how do I know what functions are available within a package? Okay, so here we use the dir function, and what the dir function is, it when you run it on a package, it will just list the different attributes and different functions that are available within the program. So here, if I open math, if I import math package and I do a dir on math, it gives me, okay, these are the attributes that are available. These are the functions that are available. Let's say one of these functions is square root and I don't know what square root function does. I want to know more about it. I can do help on math.square root, and that gives me a neat help file. So most packages come with very good documentation. So this documentation helps us to see how things are, what a function does, how it is used, some examples, and so on. So help of math.square root gives us these results, which we can use for understanding and then use it further. Okay. Additionally, if you write a document string like this, so let's say I want to use some module.py as a package. What I can do is in the start of this with 3 quotes in the start and 3 quotes in the end. So either you can use double quotes or single quotes. It works the same. You can write piece of information that will help users to see what this module is for. Okay. Now, by adding this, when you do import some modules and you do a help on some modules, you get this neat uh, representation automatically made in Python. Okay? So you get first whatever you write here. You can write help on module, some module. You get its name, the name of the package, and whatever description you have written here is now available here. It lists down all the functions that are available within the package. It lists down all the variables that are defined, data that you have stored within the package, and it also gives you the location of where this program was stored. So these are interesting things to note, that Python allows, in such ways it allows us to be more module friendly and gives us this output. So this was what we have for modules. It's a very short, crisp lecture. Do you have any questions? Okay, great. Maybe we can look at some of the examples. Let me stop this. Let's share my screen. Just a second. Okay. So let's okay. So do you want to solve some of the questions of the assignment here? I cannot hear you. Okay. Were there any problems within the assignment which were challenging, or you faced some difficulty? Maybe you can unmute and then we can talk.
No, Elijah, assignment 3 was okay.
Okay. Yeah. Did you also solve the additional examples?
Yes.
Okay, great. Sure. Then that. What about Srinivas?
I didn't check assignment really, John. In the weekend, I'll be checking this weekend.
Oh, okay, sure. So in that case, maybe I think we can stop here. I'm sorry, I'm not much prepared for this class.
Yeah, fine.
So the next thing that we will look into is we'll look into the different packages that we'll be using for analytics. They are NumPy, Pandas, and Matplotlib. I don't want to start NumPy now because we would be Yeah, it would be in a different track. Maybe we can spend this weekend on doing some more examples. I'll put up some assignments for modules, and then from Monday onwards, we'll continue with our regular pace. Okay.
Fine. Fine.
Okay.
Okay then.
Uh, uh,
Yeah, you saying
uh,
something?
no, something else. I need your help on your test. Maybe later I'll ping.
Okay. Or maybe we can like once everyone leaves, then we can continue within this discuss something.
Uh, no, I have to go and get Neeta's laptop.
Okay. Then we'll do it later.
Yeah.
Okay.
Bye.
Okay then, guys. Have a great weekend. Bye bye.
Bye.